Hey guys, in this video we shall solve another problem on LeetCode linked list cycle. So given head of a linked list, determine if the linked list has a cycle in it. So there is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, POS is used to denote the index of the node that that tail next pointer is connected to. Note that POS not passed as a parameter. So return true if there is a cycle in a linked list, otherwise return false. So if you observe we give an example 3 to 0 minus 4 and 3 is pointing to 2, 2 is pointing to 0, 0 is pointing to minus 4 pointing to again to 2. So here you can find the circle in the linked list. So this means a cycle is present in the linked list and we should return true. Similarly for this case also 2 is pointing back to the 1. If there is a single node in a linked list then you cannot have any cycles further. So how do we solve this problem? For solving this problem, we needed to choose an algorithm that takes two dummy nodes. That is nothing but slow and faster. So if you take the example, two dummy nodes, slower, and faster. Both are pointing to head initially. Then later you iterate through the loop. The condition for iterating to the loop, I shall tell that. So when you iterate to the loop, slower will be nothing but slower dot next, but faster would be two steps ahead, double of slower, that is nothing but faster dot next. So this is only one step forward, this is two step forward. So how do we do this? If you take the example 3, then 2, then 0, then minus 4, and it's minus 4 reverting back to 2, given the example. So we shall start with the very first node, slow and faster. Both nodes, dummy nodes are pointing to the head. Slow and faster both are pointing to head itself. Now slow equal to slower dot next. So you move forward. And fast equal to faster dot next dot next. So f equal to f dot next. Two steps forward. So fast will move to the second node forward to it. Again you perform slow equal to slow dot next. Then you perform fast equal to faster dot next. 1, 2. Done. Another cycle done. Now again you perform slow equal to slow dot next and fast equal to fast dot next dot next. That is nothing but two steps forward. So fast the third cycle also done. Now you can observe this slow and fast are coinciding, conflicting here, right? So this if this case occurs, then you return true. That means it is cycle in the linked list. And these two dummy nodes won't conflict each other if there is no cycle in the linked list. So how can we prove that? Again, draw the same linked list but without cycle 0, 2, then 3, 0, 2, and minus 4. So slow and faster. Slow equal to slow dot next. Fast equal to fast dot next. So fast will point here. Slow equal to slow dot next. Now you might tell fast and slow coincide. No, you have to perform both operations simultaneously and then you have to check whether slow and fast are conflicting or not. So at first we perform slow equal slow dot next, fast equal fast dot next. So S and F are pointing here. Then you perform slow equal slow dot next. Now after perform fast equal fast dot next, only then check whether S and F are conflicting. Don't just come to a condition conclusion when you perform a slow and fast operation is not done. You're having a conflict. Fine. So yeah, slow equal to slow dot next was pointing here. Fast equal fast dot next. Two steps, two nodes ahead. There is no node here. It's actually not. So this is not possible. So you can come to a conclusion that if fast dot next or fast dot next is null, then in such case you need not to perform this operation and you just need to return false. If this condition is not happening, I mean fast dot next or fast dot next is not null in any case, then you will find this conflicting condition where slow and fast nodes are meeting at some node, both pointers are meeting at some node, and you written true. So how do you conclude that if these two pointers are conflicting at a node, and that means it's a cycle, there is a cycle in the linked list. So to, to know that, we will take an example. As I told here, if you observe 3204, right, S and F, the previous condition to this was S is pointing here and F is pointing here. So that S will move one step forward and F is moving two step forward, and the conflicting is happening. So if you take example 0, 1, then 2, this is S and this is F. So S is moving one step forward, S dot next, F is moving two steps forward, F dot next not next. So conflicting is happening. So this condition is happening if F is just prior to S or S is just next to the F. Then this case will happen. How? Because S is performing only one step forward, but F is performing two steps forward. So obviously you should get a conflict, right? So this is one case. Now we'll take with four nodes. 2, 3. F is pointing here and S is pointing here. S is pointing here. Sorry. Yeah. So yeah. Here F and S are both are pointing just prior adjacent to each other. Here we'll leave one node in the between and F is behind and S is forward. So if you perform S equal to S dot next, S will go here. And if you perform F equal to F dot next, F will go here. If you look into this condition, this is nothing but the previous condition itself. F and S are adjacent to each other, where F is just prior to S, and you will encounter the same above condition here as well. So we'll take up with another example 0, 1, 2, 3, 4, where there is a gap between the S and F. Here one node was in between. Now let's take two nodes in between. So S equal to S dot next, S will point here. F equal to F dot next not next. So F will point here. Sorry. Yeah, F equal to F dot next dot next. So F will point here. Now again if you perform S equal to S dot next and F equal to F dot next, if you look into this condition, same thing here. F is just prior to S, that is the original one. Again, this operation will be encountered in this linked list as well. So any linked list it might be, you will encounter with this condition where F is just prior to S if there is a cycle in the linked list. So and you will find a conflict in some node between these two pointers, and that means there is a cycle in the linked list. So we'll code this off now. At first, we shall need to have a list node that is pointing to head. So list node, two nodes, slower equal to head, then list node faster equal to head. Before initializing this, if head is equal to null or head dot next equal to null, do we need to iterate? No. If head is equal to null or head dot next equal to null, then you need to just return false. There will not be any cycle in the linked list. If this is not the case, then you need to create, there are some nodes in linked list, and then you need to create this two dummy nodes, slower and faster, and assign it to the head. So now, while, so as I said here, there won't be any, if there is no cycle in the linked list, then we will encounter this situation where f dot faster dot next or faster dot next not next is equal to null. So while faster dot next equal to or not equal to null. If not equal to null, then we have to iterate or faster dot next not equal to null. If any one of these cases become false, then you have to return back, right? If these cases are true, any of these cases are true, then it should be and here. Yeah. If both the cases are true, then you have to perform slower equal to slower dot next and faster equal to faster dot next. So at this time we have to check whether slower equal to faster. If slower equal faster, you return true. There is a cycle in the linked list. If this is not faster, then you just need to return false. Yeah, return false. Yes, output has been given. Now we'll check it. Yeah, all the cases have been passed. I hope you guys have understood the problem. If you have any doubts, please drop out in the comment section and please subscribe to the channel for more such videos. We'll come up with another problem in the next video. Thank you.